Good day, everyone, especially to our instructor, Mr. Anthony Gamali. Good day, sir. Today, I'm going to report about the Chapter 11 Fire and Arson Investigation. So, what do you mean by fire? Fire is a chemical reaction, rapid oxidation that produces physical effects with evolution of heat and light. This creation combustion. So, fire investigation is the comprehensive analytical approach by understanding the fundamental property of fire by determining the chemistry of fires, fuels, and combustions. It is advantageous for an investigator and lawyer in case if they have at least basic knowledge about fire. So, what do you mean by arson? So, arson is a crime that involves someone intentionally burning and damaging property. Legislatures considered it as a serious crime because of the devastation fires can cause. First, objectives and purpose of fire investigation. First, to save lives and prevent injuries. Second, to determine the origins and cause of fire. 3. To provide proof of fact during trial. Number 4. To prepare to defend those conclusions in rational and legend manner supported by scientific valid data. So, the classification of fire investigation. Number 1, natural, accidental, natural. Second, accidental. Number 3, unknown origin. Number 4, suspicious. Number 5, incendiary or obvious arson. So, what do you mean by incendiary fire? Incendiary fire, this is the largest and most obvious fire investigated. The primordial intent is to destroy property or properties of another. Issues in fire investigation. 1. Lack of time. Number 2. Misidentified as accidental fire due to lack of experience. Number 3. Intentionally made to avoid complication of identifying a fire as a criminal act. Long investigative time generates negative publicity on the community. So, arson investigation. Under the law, arson is the malicious burning of dwelling, house, or building of another. So in all fires, there must be cause before an effect is produced. This cause is known as combustion. Combustion is the effect of certain causes and If these causes are not present, there can be combustion, spontaneous or otherwise. The assistance of a forensic expert plays an important role in arson investigation. Of oftentimes fire has been done maliciously. Hence, the determination of the nature and cause of the fire depends on the result of examination of an expert based on the evidence collected from the crime scene. The examination will not only save the time of the investigator but also prevent the accusation of an innocent person. So, let's proceed to technical aspects of arson cases. Burning or combustion is a rapid oxidation of substances accompanied by the generation of heat and light. Burning occurs only when three essential ingredients are present. There are fuel, heat, ignition, and oxidant. Fuel, oxygen, and heat. Obviously, to create a fire, there must be combustible materials. It may be solid, liquid, or gas. Strictly speaking, only gases burn. The solids and liquids must be heated to liberate flammable gases. The gases is turned must rise to the proper temperature before ignition occurs. Hence, there must be presence of combustible materials to burn and a source of heat to rise. Heat to raise the temperature of the fuel to the kindling point. Finally, there must be a supply of oxygen, since burning is a process of oxidation. Oxygen may be supplied from the air or from oxidizing agents. So, what do you mean by combustion? Combustion is burning at a high temperature. Exothermic redox, chemical reaction between a fuel and oxidant, usually atmospheric oxygen, that produces oxidize, often gaseous products in the mixture turned as smoke. So let's proceed to causes of fire. A fire may be produced intentionally or accidentally. One of the methods of proving arson is to determine systematically the presence of malice and intent in burning the property of another. An accidental fire may arise from working of certain force of nature or from negligence in the use of equipments and materials. Natural causes of fire. Sun rays are focused by bobbies in window panes, shaving mirrors, or by some other peculiarly shaped glasses article, which may serve as convict lens. Lightning usually strikes at a high point of the building and may be traced in its path to the ground. Traces of lightning are melting of metal parts of her building, streaked paint with burned arrows, ores, cracks in the walls, broken bricks, and soon driven into rooms from the shimmering. So, natural. There are types of natural causes of fire. Naturally occurring wildfires are most frequently caused by lighting. There are also volcanic, meteor, and coal seam fires, depending on the circumstances. Indication of fire arson. Arson is generally indicated. Number 1. Burning faster and larger than normal. So, second, often having multiple points of origin. 3. Use of accelerants. 4. A time delay device. A matchbox and cigarette is 22 minutes fuse. 5. Cans and containers are usually found at the crime scene. So, it's not accident. It's not normal accident, but it has a intent. Heat can be estimated by condition of window glass. Small shards of glass mean an explosion took place. Crazing means a hot fire. Melted copper, aluminum, and other metals usually mean an accelerant was used. Soot that wipes off, usually from glass or slightly charred studs behind the walls, means an quick fire. Combustion, nature, and behavior of fire. Combustion defined. Combustion is a burning reaction in which a substance combines with the gas, heat, and light, usually accompanied by combustion reaction, and most of this reaction involve oxygen. Example, hydrogen combined oxygen will undergo rapid oxidation and produces water and heat. Two types of combustion. 1. Flaming. Destruction gaseous combustion, where both and fuel oxidizer are gases. Flaming fire is achieved when gas or vapor is continuously burning. Number 2. Glowing. Absence of fire but presence of very hot materials on the surface of which combustion is proceeding. Two kinds of combustion. So, these two kinds of combustion. A. Complete combustion. All of the reactants are consumed. B. Incomplete combustion. Only some parts of the reactant are consumed. So let's proceed to basic combustion condition. First, presence of combustible fuel. 2. Oxidizer. 3. Energy of ignition. heat applied. 4. Interaction of fuel and oxidizer to sustain chain reaction. So, persons of combustion fuel. Those substances which can burn are called combustible substances. For example, cloth, straw, cooking gas, kerosene, oil, coal, charcoal, wood, leaves, paper, wax, hydrogen gas, ethanol, methane, propane. Flammable materials are combustible materials that ignite easily at ambient temperatures. Second, oxidizers are solid liquids or gases that react readily with most organic material or reducing agents with no energy input. Oxidizers are a severe fire hazard. They are not necessarily combustible, but they can intensify combustion or increase the flammable range of chemical so they ignite more readily. Third, energy of ignition. Ignition is the process of providing the energy that is required to initiate a combustion process. When hydrocarbons interact with molecular oxygen to combust, it requires what is known as activation energy to do so, the minimum energy needed to activate a chemical reaction. Next, matter. Matter is an element and compounds composed of atoms combined forming molecules. Air composed of 21% of oxygen and 75% of nitrogen. Oxidation is a combination of elements and compounds with oxygen producing stable substances. Pyrolysis comes from the Greek word pyro or fire, and lysis is decompose. Process of the composition of materials to simpler compounds brought about by heat from fire. Flame is a gaseous reaction where flume of hot gases rise by convection when air and its oxygen is maintained by solid or soot or liquid aerosol in a closed room. If the temperature reaches 900 degrees. Theoretically, if oxygen falls below 15%, combustion rate decreases. If the temperature reaches 900 to 1000 degrees Celsius, post flashover rooms fires which oxygen concentration is only 5 to 8%. Next, if 0 to 5% and temperature reaches to 1000 degrees Celsius, flaming hot. Nitrogen or N. Presence of nitrogen helps or delivers extra oxygen to continue the combustion reaction. Example: presence of nitrates NO3 in fuel. Color of temperature of incandescent hot object glowing fire. Here. Dark red. Dark red is 500 to 600 degrees Celsius. Dull red, 600 to 800 degrees Celsius. Bright cherry red, 800 to 1000 degrees Celsius. Orange is to 1000 to 1200 degrees Celsius. Bright yellow, 1200 to 1400 degrees Celsius. 6. White, 1400 to 1600 degrees Celsius. So the fire triangle is the fire triangle. The fuel, the heat ignition here, and oxidant here. Explosive triangle. 1. Fuel. 2. Ignition. 3rd is oxidant. Color of smoke and odor being evolved. 1. White, humid materials. 2. Light gray, hay and vegetable matter. 3. Black, lack of air with huge flames, usually petroleum based. 4. Reddish brown, thick yellow, brownish yellow. Is nitrocellulose fires, sulfur and sulfuric nitric or other chemicals. 5. Beating smoke indicates the presence of sulfur. 6. Protein cabbage like odor indicates the presence of carbon disulfide. 7. Garlic odor indicates the presence of phosphorus. Application of heat to fire investigation. 1. Heat is applied for ignition fire. 2. Heat as applied for increasing rate of chemical reaction. 3. Transfer of heat. So, transfer of heat. 1. So, types of transfer of heat. 1. Conduction. Transfer by contact between moving molecules from hot to cold areas. 2. Convection. Distribution of heat by circulating medium. 3. Radiation. Critical where it aids fire to spread and promotes ignition of other fuels. Let's proceed to types of heat reaction. 1. Exothermic. Heat is released from the system. 2. Endothermic. Heat is absorbed to the system. So, let's proceed to sources of ignition. Ignition involves burning the fuel to characteristic temperature by convection, conduction, or radiation of heat until it can sustain combustion. The following are the sources of ignition: sparks or arcs, primary igniters, lighters, hot object or surface, and friction. Primary igniters. Matches is the most common device for kindling a flame. It is composed of combustible material combined with heat containing both fuel and oxidizer that can be ignited by friction. Two types of primary igniters. 1. Strike anywhere kitchen match. The tip contains a high percentage of phosphorus schizosulfide, PS4, S3, and ground glass. Component oxidant equals potassium chloride. Fuel equals sulfur or paraffin plus binder or glue plus filler or silica. 2. Safety match will ignite only using abrasive rough materials. Component oxidant equals phosphorus. Fuel equals sulfur. Lighters. Lighters can explode when exposed to a high temperature and form a leakage when exposed to reduced atmospheric presence such as airplane. Two types of lighter. A electrical or element type, electrically connected to a battery of vehicle current etc. A. And next, second, liquid fuel lighters contains liquid butane or light petroleum as fuel in a compartment under pressure. Next, sparks or arcs. Sparks arcs are reproduced using electrical current discharging through the air or insulator or tiny fragment of burning or glowing solid. Hot object surface or surface. Hot object may convert the fuel to vapor, which eventually starts a fire. Friction. Friction between two moving objects surfaces generates heat. Example: brake shoes of automobiles can become extremely hot because of your speed. Other sources of ignition: radiant heat, chemical reaction. Other sources: fireplace and chimneys. Next, trash burners and bonfires. Next, hot molten metals. Mechanical sparks. Firearms residue during discharge of rifle. Flakes escaping from the muzzle of the short barrel handgun is a burning. These flakes can ignite finely divided cotton and similar combustibles at very close range, 1 to 4 feet. 8. Next, smoking, lightning, spontaneous combustion, ignition or electrical light linings. Next, let's proceed to laboratory identification. Recognition, collection, and preservation of physical evidence. In recognizing fire, identify first the origin. In the case, many evidence can be recovered, such as partially burned and unburned fuels. This is usually trapped in the crevice or under the collapsed chimneys or etc. In collecting physical evidence such as debris, use your nose if a vapor detector is not available. Collect as many as you can until the container is completely filled. If the container is completely filled with debris, evaporation of volatile accelerants will be prevented even if the container is open. Preservation. Usually container used in unused metal, paint, cans or glass with a screw cap. Laboratory examination. 1. Color test using Sudan black. In this method of examination, the accelerants are allowed to evaporate and the vapors are reacted with this chemical until pink color of solution will appear, which indicates the presence of any accelerant. Number 2. Confirmatory examination. Gas chromatography with head space. This analytical method is used to detect the specific volatile accelerants by comparing it with known standards such as kerosene, gasoline, and etc. How to minimize the fire. Next, how to minimize the fire. So, here are the example steps. Fire incidents can be prevented by: first, better building designs. Second, fire safety practice. So let's proceed to the tool mark. A tool is an instrument or object capable in making a mark on another object. A tool mark is defined as any impression, cut, scratch, gouge, or abrasion, or any other marking left on the object by another harder object or instrument. A tool mark may be classified as a negative impression, as an abrasion or friction type mark, or as a combination of the two. Negative impression is made when a tool is pressed against or into a receiving surface. This type of mark is usually made when a crowbar is used to pry open a door or a window. Abrasion or friction mark is made when a tool cuts into or slides across a surface. This type of mark may be made by a pair of pliers, a bolt cutter, knife, axe, saw, drill, plane, or a die used in the manufacturing of fire. Combination of mark. So combination is mark made, for example, when a crowbar is forcefully inserted into the space between a door and the door facing, and the pressure is applied to the handle of the tool to force the door open. The forceful insertion of the crowbar produces an abrasion or friction mark, and the levering action produces a negative impression. What information can a tool make provide? 1. The type of tool. 2nd, shape of cutting edge of a blade. 3rd, blade width. 4th, color of the tool based on the paint transfer from the tool. 5. Class characteristics of the tool. 6. Unique identifying marks. Uses of tool mark evidence. Tool mark may be used to link a person who used the tool in the commission of the crime, or some other acts material to the commission of the crime. Established whether B. Established whether a given tool or weapon found at the crime scene has made a mark that is material of the to the crime. C. Establish a connection between similar evidence discovered in a series of crimes. D. Crime. Determine whether a door or window was forced open from the inside or outside. E. Compared a tool mark from a crime scene with a tool mark found on the property, equipment, or vehicle of a suspect. And F. Facilitate and narrow the search of a given tool or weapon. Next, why are tool marks important in a crime scene investigation? Because tool marks are important in crime scene investigation because you can tell what kind of tools was used, what was used, and by that you can see if the suspect tools match the tool mark. Tool marks are usually discovered on doors, windows, and other openings that may have been used by a criminal in their forcible entry or exit. Particular attention must be focused on broken, forced, or cut lock and immediate area surrounding these fastenings. Entire crime scene and its vicinity must be searched for tools that may have been used. Whenever possible, submit the whole object containing tool marks to the laboratory instead of just the area containing the mark. If this is not possible, carefully photograph and sketch the area containing the mark. Cast of tools marks can be made by a person who has considerable experience in this work. Poor casts are useless for comparison purposes, and some marks will be damaged if improper methods are used. Okay, our next topic is all about the glass and glass fracture. So, glass defined. Glass is an inorganic substance in a condition which is continuous with and analogous to the liquid state that substance, but which as a result of reversible change in the viscosity as to be, for all practical purposes, rigid. Glass is normally a fused mixture of silica, usually in a form of natural sand, and two or more alkaline bases such as soda, lime, or potash. It also contains quantities of various other elements and metal present added to them for color, degrees of hardness, heat resistance, and other specific purposes. Properties of glass. Number 1. Glass is somewhat flexible. It tends to bend upon application of force. Second, glass bends on the direction where force is applied, causing of the opposite side to stretch. 3. Glass can withstand more bending rather than stretching, causing the opposite side to start breaking. The significance of knowing the characteristics of glass either is evidence or in development of investigation lies mainly in its physical properties. These properties make it possible to determine that glass fragments did, did or did not originate from the same source, or to determine the manner in which a piece of glass was broken. Glass fractures. Glass fractures may be caused by excessive exposure to heat or caused by impact of a blunt instrument or object, or caused by projectiles. Five types of glass fractures. Number 1. Radial fractures. Primary fracture resembles the spokes of a wheel where the radiating rod originates at the common point. When glass breaks, the lines that radiate from the hole are caused by the glass bending away from the point of impact. The radial fractures originate on the opposite side of the glass because this is the surface which is the first to feel the tension. As the front of the glass is pushed in, the opposite side is to bend backwards. When the limit of the glass elasticity is reached, it breaks with cracking resulting along the radial lines. Second, concentric fractures. Secondary fracture having the appearance of circle around the point in impact connecting one radiating crack to the other, thus forming triangular pieces of glass. While radial fractures are forming, triangles are created between of the fractures. A newly formed triangle bends away from the direction of force. When the limit of elasticity for the triangles is reached, the glass breaks in concentric lines. Concentric fractures originated on the front of the glass. Third, conchoidal fractures. The characteristics of glad is that when it breaks, the fracture each appears shell-like in form. That is, having elevation or depression in the shape of the shell. A technical name for this condition is conchoidal fracture. So let's proceed to fractures caused by heat. Fractures caused by heat. Fractures caused by excessive exposure to heat can be distinguished from those caused by impact, since those due to heat do not show a regular pattern of radial and concentric lines. Fracture caused by a blunt instrument or object. Through examination of glass, fractures caused by the impact of a blunt instrument or object will release a pattern of radial and concentric fractures. When glass fractures are caused by the impact of a blunt instrument object, stress lines and the degrees of both the radial and concentric fractures can be seen. Fractures caused by projectiles. A small dense object such as bullet, pebble, or steel ball may impact upon the pane of glass with such a little force, or at such a high speed that there is no bulging of the glass, and therefore no radial cracks. Penetration of high velocity projectiles would produce a coning or catering effect, where opening is larger on the exit side. Significance of determining the types of glass fractures. 1. Point of impact. Glass is at its maximum strength under compression, but weak in tension. An impact on a pane of a glass causes is the bulk is the bulk. Since the side opposite the impact is stretched more, it ruptures first. Radial cracks are rapidly propagated away from the point of impact. In short, segments ridges will be seen as irregularities on the broken edge of a radial crack. These ridges tend to be perpendicular to the side opposite the impact and parallel to the side of impact. If there is high stress, minute stress cracks called hackles or hackle. Hackler marks may also observe under the microscope at night angles to ridges. And that's all. Thank you for watching, Mr. Anthony Gamali. Thank you, sir.